Hello geometry people, it's time to combine like terms with radicals. Welcome to video number 46. For our first problem, I want to compare what we used to do in algebra to what we're going to do now with square roots. On the left side, this is old familiar stuff. If we have 2x plus 7x, we know we can combine that and it equals 9x. Then the same thing is true with radicals. Even though this looks much different, it's the same idea. Instead of x, which represents a number, I have square root of 19s. 2 times the square root of 19 plus 7 times the square root of 19 is 11 square root of 19. Oh, what am I talking about? 9 square root of 19. I got distracted there. Okay, so really this is the distributive property. I want to take a second to point that out. So let's go up here. 2x plus 7x, they both have a factor of x. This is equal to 2 plus 7 all times x. If I distributed the x again, I end up with what I started with. So it's kind of like going backwards. Usually we distribute to expand something so we can solve an equation, but when we're factoring, we're kind of going backwards. We're pulling a factor out of both terms. And now 2 plus 7 is 9, so this is just equal to 9x. It's really the same thing with square roots. 2 square root of 19 plus 7 square root of 19. Normally we don't write this step, but that's 2 plus 7 times the square root of 19 by the distributive property. As I said, you can multiply it out and get what we started with, which is equal to 9 square root of 19. Okay, so really this is the distributive property in action. This kind of used in a different way than we did with equations. So we know very well to look for terms that are like terms. The 8x and the 2x are like terms, so that's 10x. The minus 19, that's not a like term. It doesn't have the variable x, so we're just kind of stuck with it. 10x minus 19. Over here, this is really the same deal. Instead of x, we have square root of 10. It works the same way. 8 times square root of 10 plus 2 times square root of 10 is 10 square root of 10. And we still have the minus 19. So if terms have the same radical part, they're considered like terms, and we can combine them. Here we have a's and b's. We can combine the a's. 6a minus 2a is 4a. Then I have nothing to combine the minus 8b with, so we just write it, minus 8b. This is exactly the same thing. It looks kind of a bit more complicated because of the square roots, but we have two types of terms here. One's with square root of 3 and one with a square root of 10. 6 square root of 3 minus 2 square root of 3 is 4 square root of 3. And then minus 8 square root of 10, we're stuck with that. So see, it's really the same thing as if we had a's and b's, or if we had square root of 3's and square root of 10's. It's really mathematically identically the same. Okay, sometimes we have to simplify the square roots before we can combine them. Right now, the square root of 8 and square root of 50 are not like terms. But if we simplify them, who knows, they might become like terms. So my first step is just breaking apart the square roots in order to simplify. 8 is 4 times 2. And then square root of 50 we can break up into square root of 25 and square root of 2. So this is 2 square root of 2 plus 5 square root of 2. So my first step was simply to go through and break up any square roots. My second step was to simplify a little bit what I had. And now I look to see if I can combine them. Both have a square root of 2, so this is equal to 7 times square root of 2. Over here, 27 is 9 times 3, so this is square root of 9 times square root of 3 minus. 12 is 4 times 3, so this is square root of 4 times square root of 3. So this ends up being 3 square root of 3 minus 2 square root of 3, which is 1 square root of 3. Okay, here we go, 75 and 50. 25 goes into both of those. So my first step, break up the square roots, 25 and 3, minus square root of 25 and square root of 2. And then simplify. 5 square root of 3 minus 5 square root of 2. This one, they're not like terms, so I'm finished. There's nothing more I can do there. Okay, these are not like, this is square root of 3, that's square root of 2. Okay, let's take a look at this one. We have 3 terms, that's okay. I'm just going to go through break everything apart. So this is square root of 4 times square root of 6. That's 9 and 6, so square root of 9 times square root of 6. And this is 9 and 2, so square root of 9 times square root of 2. Okay, now simplify. I can take the square root of the perfect square part. 2 square root of 6 plus 3 square root of 6 plus 3 square root of 2. Okay, now, phew, that was simplification. I haven't combined anything yet, but now I look, I have 2 with square root of 6, so we can combine those. Done. Okay, so it's kind of new, kind of tedious, but I'm following kind of the same procedure every time. Simplify, or break up the square roots, simplify, and then combine like terms. Okay, 2 challenging ones. And so here, same idea, but these are, these are a little bit more, there we go. These are a little bit more complicated. Okay, but we can do this. So the first step still, break apart the square roots. We have 7. Square root of 20 is 4 times 5. Plus, we have 6. Square root of 45 is 9 and 5. Okay, so it's a lot like before, but I just have numbers multiplying the square roots. Now I can simplify that part. 7 times square root of 4 is 7 times 2, which is 14 square root of 5. Plus, this part, 6 times square root of 9 is a whole number. It's 6 times 3, which is 18 times square root of 5. Okay, simplification is done. I can combine them. 14 plus 18 is 32 square root of 5. Okay. Let's check this one out. It has 3 terms, but we can just muscle through. 4 square root of 9 times square root of 7 minus 5 square root of 4 times square root of 7 plus 16 goes into 80, so square root of 16 times square root of 5. Let's simplify. 4 times 3 is 12. 5 times square root of 4 is 10. And square root of 16 is 4. Okay, simplification is done. Now look to combine what we can combine. We get 2 square root of 7 plus 4 square root of 5. This takes a little bit of practice, but these problems where we simplify and combine, they're kind of the same every time. Break it apart, simplify what I can, and then combine. All right, you know what it's time for. It's time for our journal assignment. 3 problems, okay? So please copy the problems and show your work in simplifying, okay? Good luck. See you in class.